My dear students, I welcome all of you for this session on Internet of Things. In this session, let me study about one of the important device that acts as an endpoint in Internet of Things project. The device what we are going to study is a small computer. I can call it as a microcomputer. And that device is of credit card size. And that device I am going to make use as endpoint in IoT projects. This credit card sized small mini microcomputer what we are going to study is a Raspberry Pi. Now let us have a look at agenda of this session. At first, I will introduce you to Raspberry Pi. Once you get familiarized with what actually Raspberry Pi, we will have a look at the Raspberry Pi learning board. We will explore this Raspberry Pi board, means we will identify the microcontroller, we will identify the GPI, general purpose input output pins that are available, we will identify some other peripherals. Okay, we will identify serial interfaces, USB ports, whereas SD card slot, where I can interface camera to this Raspberry Pi computer. We will explore all this. After exploring the Raspberry Pi learning board, let me discuss about a system on chip. Okay, I said Raspberry Pi, what I said? It's a mini computer, right? Means it's nothing but a system. I mean to say, on the board what I call Raspberry Pi board, okay, there is a system, okay, and that system is nothing but a computer. Okay, clear? So then after coming to know about system on chip, we will look at the interfaces that Raspberry Pi supports. Then we will wind up the session. Now let us have a look at introduction to Raspberry Pi. So what is Raspberry Pi? I said, right, it's a small size, means size of credit card. Clear? So the Raspberry Pi is a series of credit card sized single board computers. I repeat, the Raspberry Pi is a series of credit card sized single board computers. And these computers are developed in the United Kingdom by the Raspberry Pi Foundations. Okay, I mean to say, these Raspberry Pi computers are developed in United Kingdom by the Raspberry Pi Foundations. And these computers are developed initially to promote the teachings of basic computer science in schools. I mean, these Raspberry Pi computers are developed initially to teach basics of computer science in schools and developing countries. Clear? So hope you came to know what is Raspberry Pi. What is Raspberry Pi? It's a credit card sized single board computer and developed in United Kingdom by Raspberry Pi Foundation, and is developed initially to promote teaching about basics of computer science in schools and developing countries. Now let me tell you, Raspberry Pi is used to develop the important projects. Rather than teaching basics of computer science, along with teaching basics of computer science, Raspberry Pi is used to develop some robotics projects. Got it? Now, let us have a look at generations of Raspberry Pi. Okay, so there are several generations of Raspberry Pi. So what generation means? From one generation to next generation, if I want to call, okay, it's just a generation gap. Means the computer of new generation should have been improved compared to its previous generation, right? To say, in terms of maybe the size of a new generation computer should be less than the size of previous generation, and the speed should be more than the previous generation. Got it? Also, the new generation computer should support more features than previous generation. Okay, now let us look at generations of Raspberry Pi. See, the first generation, okay, what initially innovated small computer, okay, innovated Raspberry Pi computer is Raspberry Pi 1 Model B. Raspberry Pi 1 Model B is the original Raspberry Pi computer. Then Raspberry Pi 1 Model A is innovated. After that, Raspberry Pi 1 Model B Plus, Raspberry Pi 1 Model A Plus came into existence. See, what about Raspberry Pi 1 Model B, Model A, Model B Plus, Model A Plus? They were of credit card sized. So then something still the smaller one was innovated, okay, with less feature compared to the earlier version, but the size was small, and that is named Raspberry Pi Zero. Okay. Later, the very powerful Raspberry Pi computer innovated, and that's Raspberry Pi 2. Then Raspberry Pi 3 Model B is innovated. At present, we have even Raspberry Pi 4, okay, which are not shown on the slide, but at this time we have even Raspberry Pi 4 Model B. Got it? Now let me learn about the features of Raspberry Pi computers. Okay, see, all the models which are shown in all the generations, all the models of Raspberry Pi computers of all generations shown in previous slide, okay, features a Broadcom system on a chip. Okay, it has a Broadcom system on a chip. I said there is a system on a chip on a Raspberry Pi board, and that system I call a computer, right? So computer means it has a CPU, and in this case it's an ARM compatible central processing unit. So when I say system, okay, it has a GPU, graphics processing unit. Of course, here it's a video core 4. Clear? So I mean all models features a Broadcom system on a chip, which includes an ARM compatible central processing unit and a video core 4 GPU unit. Next, the speed of CPU, okay, it ranges from 700 megahertz to 1.2 gigahertz in case of Raspberry Pi 3. And on onboard memory, like when I say computer, it should have memory, right? So the memory ranges from 256 MB to 1 GB RAM. Okay, so I repeat, the speed ranges from 700 megahertz to 1.2 gigahertz, and the inbuilt onboard memory ranges from 256 MB to 1 GB RAM. So now we need ROM, right, where the operating system is loaded, right? See here, there is what we need to burn an operating system. Okay, we need ROM. Okay, and to meet the purpose of ROM, we are going to make use of SD card, the card which you are going to use in your mobiles. Okay, so we are going to use SD cards in all the models of Raspberry Pi to load an operating system. Okay, clear? So SD card, I repeat, SD cards, I mean secure digital cards, are used to store the operating system, and the program memory in either the SDHC or micro SDHC sizes. Next, you can see that most Raspberry Pi boards have between 1 and 4 USB slots. I mean to say, the Raspberry Pi boards, okay, have up to 4 USB slots, up to 4 USB ports. We can see this while we explore the board. Okay, I repeat, Raspberry Pi boards have up to 4 USB slots. There's one HDMI interface and one composite video output interface and one 3.5 mm phone jack for audio. Got it? So I repeat, the most Raspberry Pi boards have up to 4 USB slots, one HDMI and one composite video output interface, and one 3.5 mm phone jack for audio. See, when I say input output, for computer there is an input output, right? Input device and output device. So here in case of Raspberry Pi boards, okay, for the purpose of input and output, there are pins, okay, IO pins, which we call here as GPIO, general purpose input output. pins. There are around 40 GPIO pins on Raspberry Pi boards. Next, the Model B have an Ethernet port, okay, for connecting to an internet via a LAN cable. I repeat, the Model B Raspberry Pi boards have an Ethernet port to connect to an wired LAN, okay, also as an onboard Wi-Fi as well as Bluetooth. I repeat, the Raspberry Pi B models have an Ethernet port to connect to wired LAN, also to connect to Wi-Fi. It has a Wi-Fi facility, also it has a Bluetooth. See, I said the SD card we are going to use to load an operating system. Got it? So now the Raspberry Pi Foundation supports provides, okay, one default operating system. Means it's an official operating system, okay. The Raspberry Pi Foundation provides an official operating system for Raspberry Pi, and that is Raspbian. Raspbian is a Debian based Linux distribution for download. I repeat, the official operating system for Raspberry Pi computers provided by Raspberry Pi Foundation is Raspbian, which is a Debian based Linux distribution. Raspberry Pi computers also support other operating systems like Ubuntu, Windows 10 IoT Core, RISC OS, and specialized media center distributions. And next, the Raspbian operating system provided by Raspberry Pi Foundation also provides some important programming languages like Python, Scratch, and many other. I repeat, the Raspbian operating system provided by the Raspberry Pi Foundation provides programming languages like Python and Scratch and other languages. So this is about an introduction to Raspberry Pi. Now let us see why we need to use Raspberry Pi. See, the first advantage of using Raspberry Pi is it's inexpensive. Okay. The other advantage is it's a cross platform. Why I say it's a cross platform? Because you need not have to load only a Linux operating system. It supports even Windows. Okay. So Raspberry Pi is a cross platform. Raspberry Pi is very simple to use. It supports many programming environment. It supports open source software and hardware. Got it? So why we will use Raspberry Pi? Because of some advantages like it's inexpensive, it's a cross platform, it's a simple, it supports clear programming environment, supports open source softwares and hardwares. Now Let us have a look at the technical specification of Raspberry Pi models. See, the Model A Plus is cheapest, smallest, and it's a single board computer. We know Model A Plus is cheapest, smallest single board computer. Model B is the original Raspberry Pi. Model B Plus, it has more USB ports and GPIO pins. And B Plus is ideal choice for schools. Model 2B, it's an advanced Raspberry Pi. Model 3, it's newest with wireless connectivity. Now, when I speak about system on chip, okay, Model A Plus, Model B Plus provides Broadcom BCM2835 chip includes, whereas the other two models, okay, Model 2B, it has a Broadcom BCM2836, whereas Model 3 it has a Broadcom BCM2837 chip. Now, when I say with respect to processor, Model A Plus, Model B Plus have ARM V6 single core processor. Model 2B has ARM V7 quad core processor. Model 3 has 4 ARM Cortex A53 processor. Now, when I speak about speed, Model A Plus, Model B Plus, speed up to 700 MHz. Model 2B, speed up to 900 MHz. Model 3, speed up to 1.2 GHz. Now, when I speak about the voltage required, okay, and the power required, voltage and current requirements, okay, the Model A Plus, Model B Plus requires 600 milliamps current at 5 volts, whereas Model 2B and Model 3 requires 650 milliamps current at 5 volt. Now, when I speak about GPU, Graphics Processing Unit, Model A Plus, Model B Plus have dual core Video Core 4 Multimedia Core processor, whereas Model 2B, Model 3 has Broadcom Video Core 4 processor. With respect to size, Model A Plus is 65 by 56 millimeter, whereas the other models are 85 by 56 millimeters. Now, with respect to inbuilt memory, that is RAM, Model A Plus has 256 MB SD RAM at 400 MHz, whereas Model B and B Plus have 512 MB SD RAM at 400 MHz. Model 2B 1 GB SD RAM at 400 MHz. Model 3 1 GB LPDDR2 RAM at 900 MHz. Storage, I said right, you are going to make use of SD card, all micro SD card. Now, when I speak about input output pins, general purpose input output GPIO pins, Model B has 26 GPIO pins, whereas all other models have 40 GPIO pins. Now, the number of USB ports supported. Model A Plus was having only one USB port. Model B was having only two USB ports, whereas all other models, Model B Plus, 2B, 3 and 4 USB ports. Now coming to Ethernet, Model A Plus was not having an Ethernet. Okay, whereas Model B, B Plus, 2B, Model 3 were all having Ethernet port, that is RJ45 jack. Means Model A Plus was not supporting wired internet, wired net, whereas all other models were having Ethernet port through which we can connect a computer to wired LAN. Next, except Model 3, none of the models were having wireless support. Model 3 was having wireless compatible of 2.4 GHz 802.11n. Then except Model 3, none were having Bluetooth support. Model 3 was having Bluetooth 4.1, BLE, Bluetooth Low Energy. Now audio, see all models supports multi-channel HD audio over HDMI. Analog stereo from 3.5 mm headphone jack. Good. Now when I speak about operating systems, I said Raspbian, that's an official operating system for Raspberry Pi computer provided by Raspberry Pi Foundation, and the other BMC, Arch Linux, RISC OS, OpenEL, EC, Pydora. Video output HDMI, composite, RCA. Supported resolution 640 by 350 to 1920 by 1200, including 1080 pixel. Okay, PL and NTSC standards. And how to power on the Raspberry Pi? Okay, to turn on Raspberry Pi, we need a micro USB. It has, there's a micro USB port through which we can power on Raspberry Pi. So this is a Raspberry Pi computer board. Okay, see here what and all features are explained in previous two slides. Okay, everything you can see over here. See, I said there is a system on chip, right? That you can see Broadcom BCM2835. That's a system on chip. Clear? Next, I said there are GPIO pins 40, and this 40 GPIO adders you can view on the board. And at the right side, okay, you can see there are it's written as 2x2 USB-A ports to PC, means 2x2, that is 4. There are 4 USB ports. At the right bottom you can see an Ethernet port. Okay, through this we will connect to wired LAN. At the bottom left, the label 5 volt micro USB power. Okay, through this 5 volt micro USB power, we are going to turn on Raspberry Pi. And you can see the label HDMI output, means through this HDMI output I am connecting a display, okay, that is monitor, to Raspberry Pi computer. Got it? So I repeat, through HDMI output we are connecting a display, that is monitor, to a computer. CSI camera connector. Okay, CSI camera connector means through this interface I can connect camera. 3.5 mm audio and composite audio jack. So you have earphone, right? I mean, all of you are having earphone. You will plug that earphone to your mobile and you will listen to music. The same earphone you can plug here. Not only that 3.5 mm audio jack, you can connect even USB speaker to Raspberry Pi computer. Next, see at the left, okay, there is a label micro SD card slot. Micro SD card slot, okay. And this is the slot where we are going to insert SD card, and for which we are going to load the operating system. I repeat, the SD card which is a preloaded operating system is inserted in this micro SD card slot. Clear? Then we can see USB Ethernet controller, switching regulator for less power consumption, DSI display interface, okay, and the corners, at the corner there are 4 squarely placed mounting holes. Got it? There are some 4 mounting holes. So this is about Raspberry Pi learning board. So now have a look at GPIO pins. There are 40 GPIO pins. Clear? So just have a look. The pin numbered 1 requires 3.3 volts, whereas pin number 2 it requires a 5 volt supply. I mean, it's a 5 volt pin, means pin 2, pin 4, the other 5 volts, whereas pin 1 is 3.3 volts. Even pin 7 is 3.3 volts. Sorry, pin 17 is 3.3 volts. Okay, I mean there are 2 5 volt pins labeled 2 and 4. 2 3.3 volt pins labeled 1 and 17. You can see some ground pins. Clear? Like pin number 6, pin number 9, pin number 14, pin number 20, pin number 25, pin number 30, pin number 34, pin number 39. They are the ground pins. I mean 0 volts. Got it? You can see some I2C interfaces. Clear? You can see serial interfaces, transmission, receiver. Pin number 8, that is GPIO 14, is transceiver. In case of serial communication, it is used as transmit purpose, whereas pin number 10, that is GPIO 15 is used for receive purpose in case of serial communication. Now, this exploring the Raspberry Pi learning board. In this slide, just I have described the same thing what we have studied just now. And the board means there is a Broadcom processor, okay, BCM 2837 or 2835, 2836 processor, system on chip. Power source, I said micro USB port is available. For this, I need to make use of adapter, which is suppose 5 volt and 2 amps current. 2 amps, I repeat, 2 amps current. Okay, next the SD card to which I am going to load an operating system. Okay, it should be at least 8 GB capacity. It should be of at least 8 GB storage. So GPIO we have seen DSI display X. Okay, DSI display X for connecting LCD panel. Okay, for connecting an LCD panel. Then we have seen audio jack. I said right, the earphone what you are using for your mobile, you can plug it to this Raspberry Pi computer. Not only your earphone, you can even use USB mic, USB speaker too. And there are some 5 status LEDs. Okay, 5 status LEDs on Raspberry Pi. What are those LEDs means? GPIO 16. Okay, it means OK, means SD card access. The next is PWR, 3.3 volt power on all boards. Next, FDX, full duplex. It means full duplex status LEDs. Okay, OK means SD card is accessible. 3.3 volt power PWR. FDX means full duplex. LNK means link activity. 10 amp by 100 LAN. Also we have seen Ethernet port. I said we have seen camera serial interface. I said right, and to which we are interfacing camera. HDMI, I said is a port, HDMI output, to which we are going to connect a display or a monitor. Now let us review system on chip. So what I said, system on chip, it's computer. I should call it a computer, right? So here system on chip means it's an integrated circuit. It's an integrated circuit, and it's an integrated circuit that coordinates all parts of a PC or other electronic framework into a chip. So system on chip comprises it as a microcontroller. Okay, it has a microcontroller. It should have a microcontroller. It has memory pins. Okay, ROM, RAM, EEPROM. It has crystal oscillator. Okay, timing source. It has peripherals like counter clock. It has interfaces to the outside world, that is using USB or Ethernet port. It has some simple interfaces like ADC, analog to digital converter, DAC, digital to analog converter. It has voltage controllers and power administration circuits. Next, Raspberry Pi interfaces. Serial interface. See, I said two pins, one pin for receive and the other pin for transmit for communication. Let me show you back in this pic. See here, the pin labeled GPIO 14, GPIO 14 is for transmit. GPIO 15 is for receive purpose in case of serial communication. Serial peripheral interface. A synchronous serial data protocol is used for communication. A synchronous serial data protocol is used for communication with one or more peripheral devices. Okay, here there's one master device and one or more peripheral devices, and there are some modes. Okay, what we call MISO. MISO means master in, slave out. Here master line sends data to peripherals. The next one, MOSI, means master out, slave in. Slave line sends data to master. SCK means serial clock. Clock generated by master to synchronize data transmissions. C0, chip enable 0, to enable or disable devices. C0, chip enable 1, to enable or disable devices. I2C. The I2C interface pins on Raspberry Pi allow you to connect to hardware modules. Okay, I mean you want connect your Raspberry Pi computer to Arduino, or you want to connect your Raspberry Pi computer to another Raspberry Pi computer. Okay, there you can make use of I2C interface. And this allows synchronous data transfer with just two pins. One is SDA data line and one is SCL clock line. So this is about this session. Thank you for listening.